Today we are joined by Michael Ulin, CEO and co-founder of Tenki AI, which uses multi-agent systems to forecast prediction markets like Polymarket and Kalshi with 76% accuracy. Michael is a serial AI founder, founding engineer at Zesty AI for 7 years, building wildfire risk models for companies like Farmers Insurance and Berkshire Hathaway. Then he founded Paxton AI, a legal research AI assistant that raised $22 million. Tenki, he is applying Agentic AI to beat prediction markets. Michael, welcome to the show.
Great to be here. Thanks for having me.
So let's start with the basic question. What actually works when building agents that real customers pay for?
Yeah, I think understanding the limitations of agents is important when you're building production systems and making sure that you communicate those to the customer. So, a lot of people try to make AI sound like magic and it can do anything, but really understanding the use case, the limitations, and making sure you're communicating those to the customer so that they have the proper expectations. I think there's a temptation a lot of the time with technology or with startups or software companies to focus a lot on the technology part, which is really important. But I think equally important, or maybe even more important, is communicating expectations to your customer and making sure that they can actually integrate this into their workflow. So with Paxton, a big problem with AI or LLMs is hallucinations. So in the legal industry, there's like probably a news story every week about a lawyer getting in trouble for citing fake case law or fake court cases, which is a problem with out of the box LLMs like ChatGPT or Gemini or Claude. And so with Paxton, we really focused on that problem and making sure that we had accurate citations for all answers that were generated. So it's a RAG system connected to laws, rules, court cases. And for every answer, you got a citation back to the primary source material. And that really helped build trust with the users, let them verify the results. And so it wasn't just answer coming out of nowhere. You really let people see the reasoning and the logic behind the result. Same thing with Zesty and producing underwriting or wildfire models. People wanted to understand, not just that this property was at high risk for a wildfire, but they also wanted to understand why, like what were the factors that drove this decision. And so you could see like, oh, well, this home is surrounded by a lot of trees. So that's why this score is very high. And that's what we're doing at Tenki. You get, for every market that you want to analyze, you get not only our predicted probability, so what we think the market price should be, but also the underlying factors and analysis of why that score is the way it is. And that helps build a lot of trust with the users, because when you're building with AI, it's not going to be right all the time. It'll be right the majority of the time, but you really want to make sure that you're documenting your reasoning, showing the underlying that drove a particular decision, and that helps build trust with your users. And that's what I've found really works well when you want to put these things into production.
Awesome. So walk us through the Tenki's multi-agent architecture. How many agents do you currently have? What does each one do? Like how do they coordinate the information with each other?
Yeah. So with Tenki, we are taking the best of forecasting techniques that have been proven in domains like economics, political science, analytics, and we're encoding those into AI agents. So each agent is responsible for a different component of the forecast. So when people do this, and they want to produce a really accurate forecast, it's extremely labor intensive. You need to do a lot of research. You need to produce a model. You need to challenge your assumptions. And, it's been shown in many studies that if you do this consistently, you can produce a forecasts that are more accurate than random chance. It's not like you're going to perfectly predict the future, but you can do better than someone just relying on gut feel. And so we've taken those techniques and applied them via AI agents. So an agent is responsible for each component of the forecasting workflow. So there's a research agent that collects all the relevant information. There's an agent that breaks down the forecast into different key factors. If we want to forecast who's going to win a football game or a basketball game. We can decompose that question into, well, what are the fundamentals of each team? Like, are they stronger on defense? Are they stronger on offense? Are they facing any injuries? Did they have a really hard travel schedule? So each of those, that singular question of who's going to win, then gets broken down into these subcomponents, and then we do analysis on each one of those subcomponents, which then ends up producing the forecast. And another big component of doing well at forecasting is challenging your base assumptions. So we actually have agents that take the role of uh, base. So really arguing in the affirmative for whatever we're trying to forecast, and then the bear case. So really trying to pick apart and poke holes in the logic of the forecast. So we have agents kind of engage in this debate about, is this forecast going to be correct or not? And then at the end, that's when you get the actual predicted probability along with the underlying analysis to the user. So that's another agent that's responsible for there. So I think when you break apart a harder problem like that into subcomponents and assign each subcomponent to an agent, that ends up working far better than if you had just a single agent or a single LLM call that's responsible for everything. I think when you break something up into these smaller subtasks, that's when these AI systems can really shine. Versus if you overwhelm it or try to ask it to do too much, that's when it can stumble. So breaking down a problem into smaller pieces helps these systems perform better.
So, what are some of the challenges you faced when you broke the things down? Because I know LLMs lose context and sometimes they hallucinate. What kind of challenges did you face when you first started to build this?
Yeah, I think having a background in data science or machine learning definitely helps when you're designing these systems. I see a lot of people fall down who are coming from like a traditional software engineering background, and trying to apply those like deterministic techniques to what is inherently a probabilistic system. But I think just having some good basic practices around logging and evaluation can really help people when designing these systems. So recording everything that the system produces, what were the inputs, and then what was the resulting output, and then having some way of grading that output. So for us, in the prediction market space, we can see how an event resolved. We can see who won the game. So we can see if something was a valid forecast or not, and then go back and try to address any deficiencies in the system. So having a record of what was the input, what each of the steps in the pipeline produced, and then what was the resulting output, and was that output good or not, really helps you debug and understand how to improve the system. So making sure you're keeping good track of that, and then you can use those records to actually make improvements or refine each component of the system. And you want to be methodical about it by testing changes, like scientific method or running experiments. You don't want to, like, if you change too much about a system, you're not going to be able to attribute an improvement or a degradation to a particular change. You have this complex pipeline, you change one thing at a time, look how that affects performance. Was it good or was it not? And you can use this to iterate and refine the performance of the system. There's a great Python package out of Stanford called DSPy that if you're logging all of this data, you can use this to refine the prompts for each of your agents. So if you have, say, a set of outputs that performed really well, you can say, I want a prompt that generates outputs of this quality. And it will automatically write that prompt to try to optimize that data set for the best quality of outputs. But you can only do that stuff if you're logging everything appropriately, if you're keeping track of some metric of performance. And it might vary based on your use case. Like for Paxton, it was like how many of the records that we pulled were the correct ones for this question. Or for Zesty, it was was a property affected by wildfire, or was it damaged by an event? So you'll have to pick the metric appropriately, and then you can start optimizing for it. But you got to break down the question, examine each of the components, and kind of be methodical in how you improve each one.
So what kind of information do you normally log? So is it just like the input and output and like its thought process? Is that it? Or is there anything else that you normally like to log? Or is there any like kind of context that you also log as well? So you always try to keep track of the current context, and then based on that context, you log what's there. And I'm just curious, what is the level of like detail that you provide?
You want to be extremely detailed, and I think the more you can log, the better about the state of the system at a particular time. So not only what were the inputs, from the user question down to the sources that were used if you're doing something like a RAG system. And then if you have a multi-agent pipeline or a multi-agent system, logging the inputs and outputs for each of those agents so you understand what exactly happened in this pipeline to produce an answer. So if you have something complex with multiple steps, you're going to have to log the results of each of those steps so that you can figure out, like, not only did the whole pipeline produce a accurate response, but uh, each of each of the subcomponents, how did those perform, and could one of those either be contributing to the overall performance of the system or hurting the performance of the system? So I think it's really hard to go back and reproduce a state if you haven't logged all of the steps. So I try to err on the side of logging more rather than less, because it's just really hard to reproduce a state of the system when it gets really complex.
Especially when it's a multi-agent output and it's very hard to orchestrate it. So how do you prevent overfitting? So like you do prediction, right? And you test it on new markets and old markets, and you have an optimized model. So all of your agents are working off of a set of prompts. They have been optimized by you, and they produce that 74%, 76% accuracy. How do you avoid overfitting it, or how do you generalize it? So if you drop it into a new market, it would work, or do you have to basically optimize it for each market?
So I think the reason we picked prediction markets was kind of born out of prior experiences that we've had. So back when I was doing insurance models at Zesty, like, you could backtest a lot of performance, but you really only knew how the model performed when an event happened, when a wildfire occurred or a hailstorm occurred, a wind event occurred. I mean, those, they get a lot of attention in the news, but they only occur a couple times a year, even over a large area. So the data to actually validate whether the model was working or not, like, it's pretty sparse, pretty rare to get, and so very precious. And with prediction markets, we have markets that are resolving every day, which is great for testing predictive models, because we can make a set of predictions in the morning about events that are going to occur that evening, and then see how they resolved. And I think it's really powerful for these types of models, because you can't overfit to an event that hasn't occurred yet. So because they occur all the time, and you can check pretty clearly if you were right or not, you can just have like a lot faster feedback loop than if you were predicting something that, like a weather, like a climate risk, like we're doing at Zesty. If you're trying to predict something that only occurs a couple times a year, you don't have that rapid feedback loop like we do at Tenki. So I think that's one of the things that's really powerful here, is like, you don't have to rely entirely on back testing to validate a model, which, you try to make a back test as clean as possible, but ultimately the ultimate test of the model is how it's going to perform on events that haven't occurred yet. And with prediction markets, we're getting that feedback loop just rapidly, versus only a couple times a year in other domains. So I think that makes our pace of iteration and improvement a lot faster than what we were doing in other fields.
So what is the cost per prediction? How many agents are you running? What is like the total number of agents like in your pipeline? And like, what does the total cost for prediction look like? Because I can imagine having multiple. Are you like, or is it a combination of LLMs and SLMs, or are you just using like of the shelf agents? How does that work?
It's a combination of larger models and smaller models. And the great thing about the space is everything's just improving so rapidly. Even the smaller models are super capable compared to what they were like even a year ago. The final output is a larger LLM, and then the components of the system rely on smaller LLMs, and that's one of the reasons that breaking tasks into smaller subcomponents is really helpful. For smaller models, they can really excel at extremely well defined smaller tasks, but they tend to break when you give them like a multi-step problem to tackle, and even the larger models will break when you give them a larger task to look at. So we have about a dozen agents that coordinate for this, and each prediction can take a couple dollars to produce, but compared to compared to what a human would be doing to produce a forecast, like some of these forecasts, like who's going to win a NFL game, an NBA game, or what's going to happen with economic or geopolitical events. A human might take hours, weeks to produce one of those forecasts. And I think that's a big reason that we don't do more this rigorous forecasting type work is just how expensive it is, how it requires like very specialized experience, either from like an economist or a statistician. So we only reserve this type of rigorous forecasting work for really high value applications today. But I think the power of Tenki and the power of AI agents is that we have this PhD level intelligence available via API call that can run through this work in minutes instead of hours or days or weeks. And so we think that like we can apply this rigorous forecasting methodology to a wider variety of problems than we've ever had the capability of doing before. And that's why we're super excited about this opportunity here.
So what is the like long form vision? So will you be able to take the learnings that you got from prediction markets and apply this to things that are not in the prediction market? Is that what I'm hearing?
Yeah, that's the long term vision of Tenki, is that because we're building these models, these agent systems, and iterating and refining them at such a rapid pace, we can then take these refined models and apply them outside of prediction markets. So a lot of the types of questions on prediction markets are things that are relevant. What will GDP be, or what is the forecast for inflation, or what will unemployment be? These are typically questions that require like an economics consulting firm to answer. And beyond that, I used to do work in consulting at McKinsey and Company, and we would be called in to do forecasts all the time. So if you're working for like a big car company and they're thinking about building a factory, you would want to do a forecast of what will the demand for trucks be in 10 years, because that's when the factory will come online. And so that those types of questions, that type of work, we ultimately think that's where Tenki will be applied. We want for every business decision that you consult a Tenki forecast to help make a better decision, make a better informed decision, instead of strictly relying on gut feel. And but that's the longer term vision for the company.
That's extremely valuable. Makes perfect sense. So, as a person who has built AI agents across like insurance, legal, now prediction, what is the common playbook that somebody can follow when they're building their own agent and launching it to production? What are some of the things that you've learned building these three companies?
I think it's not just common to it's not just applying to AI agents, but startups more broadly. Is you should launch a product as soon as possible, even if you feel like you're not ready. Get it into the hands of the users. Get it in the hands of people who are actually trying to solve a problem and get feedback. I think there's this temptation to like try to do a lot of work before you launch and polish, get it really ready for when you're ready. But there's that old saying, no plan survives contact with the enemy. You can do all this work up front, but you're really going to start learning once you put something out into the world and have people use it. And so getting to that point as quickly as possible, I think, is really important, so that you have feedback and are you really solving the right problem that's valuable to your end customers, to your end users? Because that's going to be the true test. If someone tries to use it to solve a real problem versus like you can be really smart and kind of speculate about how people might want to use something, and you could be a domain expert, you can have worked in the field for years, but you're really only going to truly learn once you put that product into the end user's hands. So I think what I've learned over these three ventures is try to get to that point as fast as possible and work with your customers, get feedback from them, and iterate really quickly. I think that's how you make a really great product. Uh, that's how you avoid spending a lot of time building something that people don't want or people don't value. Is to get it out into the world, get feedback, and iterate.
And what advice would you give to founders who are building agents right now? Like, what are people overcomplicating or over engineering in their tech stack?
Yeah, I think this question of evals is usually where I see like not enough attention paid, and where people can really fall down with these systems. They produce a demo that works really well, as a demo, or works well 70% of the time. And once they go to try to put that in production, they try to scale up this same demo system, and it breaks on all of these edge cases, and they're not logging those events. They're not logging those real world interactions, to understand exactly how to improve the system. So that's where I usually see these things fall down. Is there hasn't been a great job of like defining a metric that you can optimize towards, like accuracy or response quality, or the quality of, if you're doing like a RAG system or something that retrieves information, the quality of the information that you've retrieved. So defining that metric that's important for your business, making sure that you log all of the inputs and outputs, and then optimizing towards that metric. I don't think enough people do that from the beginning, and I think that's really important in getting to these systems to work well in production.
So, sort of like the North Star. So, in terms of Tenki, what is that metric?
For us, it's forecast accuracy and something called a Brier score. So we want to make sure that we are accurately predicting these markets. We're not going to be 100%, but we want to see that number go up over time. And then Brier score, for folks who are not familiar, is based on the predicted probability of the model. Are we more confident in events that actually occur, and less confident in events that don't occur? So the Brier score will penalize if I say an event has a 51% chance of occurring and it does occur, I'm going to get less credit for that if I said the event had a 90% chance of occurring and it does occur. Conversely, if I told you that the event had a 90% probability of occurring and it did not occur, that's going to be penalized more heavily versus an event that I said had a 50% chance of occurring and did not occur, or a 40% chance of occurring and did not occur. So we want that predicted probability to be well calibrated, so that, if we tell you that this event has a 70% chance of occurring, it occurs 70% of the time over all the forecasts that we do. So those are the two things that we really try to optimize.
Interesting. So, how did you start with your product launch? What kind of marketing did you do to get your agents out there and to get people to know?
So I'm a big believer in validating that there's actually demand for what you want to build before you build it. So we launched with just a landing page and a wait list before we even had a product. So we put up a landing page, said, "Hey, here's what we're thinking of building. Would you sign up for a wait list? Would you want to be notified when it's available?" And that gave us a list of customers who were interested in this. It gave us a list of people who would talk to us about the problem. And so that gave us confidence that there was real demand for what we're doing. And so we did that before we built the product. Because if someone's not, if someone's not willing to put down their email address on a web form for your product, I think, that's a pretty good indicator that there's not demand for what you're doing. But a lot of people take the opposite approach and say, "Oh, I'm going to build it, and then the demand will follow." So I always try to validate that there will be demand for what we're doing before we go build it. So I think yeah, and it's not like saying that you have something before you do, but just say, "Hey, here's a waitlist sign up for what you're doing. Do you want to be notified of updates on this, and will you sit down for 15 minutes and talk with us?" I think that's another really great indicator that a problem is important. I mean, it's not sufficient to prove demand, but if your customer is not willing to take 15 minutes out of their day and talk to you on a Zoom call about their problem, I think that's another indicator that that's not a really great problem to be focusing on. So I think there's very simple things you can do up front to validate that demand, and that's what we try to do. That's what I try to do before launching a product.
So you got the first of all I guess your wait list. You're sending out some newsletter, and then you launch the product. You launched it at $10 a month. Why $10 a month? I mean, is that what you thought the traders would pay, or do you charge commission on top of those predictions, or how did you come up with the $10 per month, or is that just to validate your like product in the market before you kind of set up like proper
Yeah,
business model?
it's pretty arbitrary. It's mostly to validate demand. I mean, I think we're delivering value in excess of $10 a month, but it's kind of this walk, crawl, and strategy of, will people sign up for a wait list? Will they talk to us? Would they put down a credit card for $10 a month? And then as the product gets better over time and we understand our customer base better, making sure that we're delivering improvements, and the early customers get to stay at their low price, but can we charge more as we're delivering more value over time? But each of these steps is to validate that there's demand and a willingness to pay for the product. And so, I think like that's just, it's kind of the next step in this evolution is like, okay, will you put down an email? Okay, will you put down a credit card and pay $10? Like, you can kind of start at the end state, but I think it's a lot harder than, kind of building up gradually to where you.
Now, this makes sense, especially if you want to be an AI that predicts anything for anything, basically the ultimate prediction AI. Then you need to validate it and validate with real customers and iterate based on the feedback, and then eventually come up with those corporate offerings that would probably be more than $10 a month. It makes perfect sense. So you have decided to bootstrap the current companies. Thank you. You were in two venture funded companies before that. What made you choose to bootstrap this one?
We have venture funding for this. We haven't announced it yet, but more coming soon. But I do think the capital requirements of businesses are falling, so that bootstrapping is more and more feasible, or running a business with a smaller amount of initial capital is more and more feasible. It's just kind of been amazing to see the fall and what's required to get a business off the ground these days. Like, if you imagine, doing a startup in the 90s or early 2000s in the first internet boom, you had to build your own data center. You needed your own servers, and you needed someone to manage those servers. And fast forward to today, you can spin something up on AWS or Google Cloud in an instant, and you don't have to worry about, do I have the right amount of infrastructure, or do I need a person who specializes in actually managing physical infrastructure anymore? That can be outsourced. There's an amazing amount of resources out there now in terms of we outsource our payroll to a company called Deal. Like, they handle all the compliance stuff. They handle like onboarding, offer letters. And you can delay kind of that HR hire. Same thing in terms of like finance and accounting. We've kind of atomized all the different components of getting a startup off the ground, such that a very small team can just rely on these outsourced providers for what they need, and you don't have to do everything in house, and you don't need as much money to you don't need like a general counsel from the start. You don't need a HR person. You don't need a finance person from the start. You can rely on this kind of ecosystem of smaller automated providers to get things off the ground in a way that even 20 years ago, 10 years ago, just wasn't possible. We did raise money for this, but you know, I think the amount of capital that you need to get something off the ground and the amount that you can do uh, on your own uh, is just extraordinary today. And so it's a really exciting time to be building something.
So, one final question. What should somebody who is currently listening to this be building? What is an opportunity that nobody is talking about, but you see value in? What kind of agents should people consider building right now, and in which space?
Yeah, I mean, I think if you're passionate about a problem that you have in your own life, try to solve it with an AI agent, and then make sure you validate that the demand exists elsewhere. But if you feel strongly that you have this problem, there's a good chance that others do, and I think those are the best problems to focus on and solve for you're your own first customer, and you really have this problem that you feel viscerally or acutely. And in terms of like some macro trends, like I think information overload is only going to get worse as the cost of producing content goes down. So agents that can help you triage and understand the world, and kind of like what we're going to see, I think there's a tremendous amount of opportunity there. But I think the best place to start for a lot of folks is to solve a problem that you have yourself, and then make sure that you can validate it by I mean, there's so many great channels available now, from Reddit to Discord to Twitter, to get feedback on your idea. So, go solve one of your problems, go talk to people out in the world and see if they also share that problem. But I think that's just where I would start.
Hello, everybody. This is Michael Ulin. Check out Tenki AI, and thank you so much for joining the podcast today, Michael.
Yeah, thanks so much for having me on.